Hello, I'm going to go over this lecture, Spiral and Elliptical Galaxies, and we're just talking about some of the obvious features that we see with each of these galaxies. Now remember, galaxies are made up of billions of stars. So this whole image that we see of this galaxy, that cloud, those clouds are stars, billions of them. So let's take a look here, and the most obvious thing we see are these spirals, these arms that come around. Spiral galaxies have distinct arms that turn around the center of the galaxy. Often we see a bulge of stars right here. We see a bulge. And if you saw it on its side, it would also bulge out right in that middle part. We see a bulge of stars in the center and a bar through the bulge. So this long straight area here is the bar through the bulge. All right, so down here, how is it that those spiral arms start to form when a galaxy first is being created? So early on in the formation of a galaxy, differential rotation causes the arms to start to form. What that means is, as two clouds come together, two nebula come together to start forming a galaxy with all these stars in them, some areas spin faster than others. So at the center, you're going to get the rotation around the center is going to be different close to the center than it is at the outside. And so you get this twisting up as these inner stars twist around the center at a higher rotation. As the galaxy ages, the twisting of the arms slows down and it starts to stabilize, where now they're starting to move at the same rate. But early on is when those arms, those twisting arms form because of this differential rotation. All right, so some more stuff about spiral galaxies. We see this image here in this really bright location. So this radio image shows evidence of a supermassive black hole at the center of our spiral galaxy. And that's what we see here. We don't actually see the black hole. We see parts of the electromagnetic spectrum, in this case radio waves, that are coming off of material swirling around the black hole. So that's what we're seeing here. You can't actually see the black hole, just evidence of the black hole. And at the center of spiral galaxies, it's not just a normal black hole, it's a much, much bigger black hole. The black hole has a mass of 4 million suns. So the black hole at our center of our galaxy has a mass of 4 million of our own suns. And this is common. We've seen this be in other spiral galaxies as well. Another piece of evidence about a black hole at the center of our Milky Way galaxy. Another piece of evidence for the black hole are the orbits of the closest stars. So each of these is an orbit of a star that is close by or near the black hole. And you get these really elongated orbits. They are highly elliptical, and the stars speed up as they get closer to the black hole. So the closer as they're coming in towards the black hole, they start going faster and faster. And then as they loop around and go away from the black hole, they start to slow down. And that just keeps repeating that pattern. So again, this is evidence, since we can't see a black hole, this is evidence for the black hole. All right, now a couple things about elliptical. Elliptical galaxies do not look like the spiral galaxies that we saw before. They kind of look like a big spherical cloud of stars. There's still billions of stars here, but it's just this haze. They all blend together, and it's this haze of stars. no spiral structure. So elliptical galaxies have a spherical or football shape, and they do not have spiral arms. The stars are held together by gravity, but orbit in different directions. So they don't all orbit around a center in the same direction like in a spiral galaxy. Elliptical galaxies form when two spiral galaxies collide. And we see that in this picture here, this image, where you see two small spiral galaxies eventually come together. And as they do that, as they combine, it breaks up the formation of those galaxies because of the different gravities of each. And then they eventually settle down into more of a spherical or kind of like blob-like structure. This will happen to our Milky Way galaxy and the Andromeda galaxy in about 4.5 billion years. All right, I hope this helps. Thanks.